Hi, this is Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical. Today, we are going to discussing about electrochemical cells. Electrochemical cell is the device which convert chemical energy, to electrochemical energy. Whereas in electrolytic cell, it is defined as the cell or device which convert electrical energy into chemical energy. So depends on this type of cells. Batteries are classified into two types: primary batteries and secondary batteries. So if you take primary batteries, in most of the cases primary batteries are act as a electrolytic cells. That's why we can call it is these are the non-rechargeable batteries. Non-rechargeable batteries. Whereas if you take secondary battery, in secondary battery is act as a electrochemical cell. That's why we can call it as secondary batteries are rechargeable batteries. Rechargeable batteries. Why? Because why we can call it is secondary battery is electrochemical battery? Why? Because it is a rechargeable batteries. So if you take rechargeable batteries, we can observe two types of reactions. That is discharging and charging. Discharging and charging. So what happened during discharging? Chemical energy during discharging process, chemical energy convert into electrical energy, whereas during recharging process, electrical energy convert into chemical energy. So during discharging process, chemical energy convert into electrochemical energy. Chemical energy convert into electrical energy during discharging process, whereas during charging process, electrical energy convert into chemical energy. So that's why we can call it is secondary batteries are rechargeable batteries. Let us see the what is the construction and working principle of electrochemical cell as well as electrolytic cell. So first, let us discuss about construction and working principle of electrochemical cells. So look at here, this is the construction of electrochemical cell. Electrochemical cell made up of two half cells which contains anode and cathode and their corresponding subs. These two anodes and cathodes are connected physically contact with each other through an external wire. And here U-shaped tube which is connected in between the anode and cathode. It is act as a salt beach. So half part of the cell we can call it is anodic compartment, and the remaining part of the cell we can call it is cathodic compartment. So it is a Daniel cell. Example for electrochemical cell is the Daniel cell. Here we are using zinc as a anode, which is dipped into the salt of ZnSO4, and cathode is copper, which is dipped into the salt of copper sulfate. Here, anode and cathodes are contact with each other through an external circuit. So, oxidation takes place at anode. As we know, oxidation takes place at anode. So, what is the oxidation? Release of electrons. Removal of electrons is nothing but oxidation. So, electrons are released at anode. These electrons move towards cathode through an external wire. Here, copper acts as a cathode. Copper gains electrons which are coming from anode, forms a copper sulfide. So, these anodic and cathodic compartments are separated to each other, are connected with each other through a U-shaped bent tube, which is known as salt beach. Salt beach contains saturated KCl solution, KNO3, either NaOH and ammonium chloride. Ammonium chloride. So, this is a construction. And what are the functions of salt beach? Salt beach, it eliminates the liquid junction potential. It provides elliptical continuity between the two offsets. And major role of salt beach is to maintain elliptical neutrality inside the circuit. So let us see what is elliptical neutrality. Suppose when the reaction takes place, that is oxidation reaction, electrons are released at anode. That electrons moves towards cathode, and Zn reaches the ZnSO4 solution as a Zn plus. Zn plus. It is neutralized by passing Cl ion into the anodic compartment from salt beach. So Zn and Cl2, it will be neutralized. So anodic compartment will be neutral. Whereas similarly, Cu gains electrons and it is deposited as Cu, and SO4 remains in the compartment. This SO4 react with potassium, which is coming from salt beach into the cathodic compartment. So that is a neutral. So due to the presence of salt beach, both compartment should be neutral. That is a major role of salvage. So that is the functions of salvage. Next, coming to the reactions. So Daniel cell represented as Zn/ZnSO4, and this is a salvage in between the two salts of zinc and copper sulfate respectively. So at anode, oxidation reaction takes place where the release of electrons, and at cathode, reduction takes place. So that is about construction and working principle of electrochemical cell. Next, coming to the applications. What are the major applications of electrochemical cells? Electrochemical cells are used in electrorefining of many non-ferrous metals. They are also used in electrowinning of the metals. And metallic sodium can be extracted from molten sodium chloride by placing it in an electrolytic cell and passing electrical current through it. And many commercially important batteries, such as lead acid battery, are made up of galvanic cells. And fuel cells are an important class of electrochemical cells that serve as a source of clean energy in several remote locations. Next, coming to the electrolytic cell. So, already we discussed about what is the difference between the electrochemical cell and electrolytic cell. In electrochemical cell, chemical energy converted into electrical energy, whereas in electrolytic cell, electrical energy converted into chemical energy. That means in electrochemical cell, reaction is initiated by chemical present in the whatever chemical present in the cell in the form of electrolyte. Whereas in electrolytic cell, reaction is initiated by in the presence of DC, direct battery. So let us see construction of electrolytic cell. Electrolytic cell contains only one compartment which contains molten sodium chloride as a electrolyte. So here we are using inert electrodes. In electrolytic cell, we are using inert electrodes. So when battery is connected in between these two electrodes, so in the presence of current, sodium chloride NaCl is dissociated into Na plus Cl minus. Na plus Cl minus. So electrons passes towards cathode, and these electrons are gained by sodium ion, Na plus ion, and it is deposited as Na at the cathode. Similarly, oxidation takes place at anode, releases electrons, and these electrons are gained by Cl, and it is deposited as a gas at anode. So that is the construction of electrolytic cell. So two inert electrodes are dipped into molten sodium chloride, which contains dissociated Na plus cation and chlorine anions. When an electrical current is passed into the circuit, the cathode becomes rich in electrons. Why? Because electrons are moved towards cathode. Why? Because cathode is the positive charge here. So negative electrons are attracted by positive charge of the cathode. So cathode will become electron rich. The positive charged sodium cations are now attracted towards the negative charged cathode. As a result, in the form of metallic sodium at the cathode. So simultaneously, the chlorine atoms are attracted toward N. The result in the formation of chlorine gas at the end. Next, coming to the chemical reactions in electrolytic cell. So, reaction at cathode. Gain of electrons, reduction takes place. Here, reduction takes place. And at anode, oxidation takes place. Coming to the next cell reaction, Na plus Cl. Thus, molten sodium chloride can be subjected to electrolysis in an electrolytic cell to generate metallic sodium and chlorine gas as the products. So, products are sodium, metallic sodium, and chlorine gas. So, during electrolysis of molten sodium chloride, metallic sodium and chlorine gas are found as a products. So, that is the working of electrolytic cell. Coming to the applications. What are the major applications of electrolytic cell? So the important and major application of electrolytic cell is production of oxygen gas and hydrogen gas from water. They are also used for extraction of aluminum from bauxite. So we know that bauxite is the ore of aluminum. So with the help of electrolytic cell during electrolysis process, aluminum can be extracted from bauxite. And another important application is electroplating. So it is a protective method of corrosion. Electroplating is an important application of corrosion prevention methods. It is one of the corrosion prevention method. So it is also depends on electrolysis reaction. And next application is electrorefining of many non-ferrous metals. It is done with the help of electrolytic cells. You can see here what is electrowinning. Electrowinning is also called as electroextraction. It is a process in where the metals such as gold, silver, copper are recovered from a solution by means of electrolytic chemical reaction. So during electrolysis process, extraction of gold and silver and copper. That process is known as electrowinning. Electrorefining uses similar process to remove impurities from a metal. So these two processes are electroplating on a large scale and are important techniques for the economical and straightforward purification of non-ferrous metals. So these are the construction and working principles of electrochemical and electrolytic cell. Now let us see what are the major differences in between the electrochemical and electrolytic cells. So let us see. First, in electrochemical cell, chemical energy converted into electrical energy. Whereas in electrolytic cell, electrical energy converted into chemical energy. It is a spontaneous process, redox reaction. Here, what is a spontaneous? That means it is a independent. Why? Because it does not depend on battery. Here there is no external source. In case of electrochemical cell, here there is no battery. You can see here construction of that electrochemical battery. So in electrochemical cell there is no DC external source. There is no external source. So reaction is initiated by whatever chemical present in the form of electrolyte in the cell. So that's why we can say that it is a spontaneous process. Spontaneous is nothing but independent process. Whereas in electrolytic cell, it is a non-spontaneous process. Non-spontaneous means dependent. So in electrolytic cell, it depends on external source. That's why we can say that it is a non-spontaneous process. In both cells, redox reactions takes place, but spontaneous redox reaction takes place in electrochemical cell. Non-spontaneous redox reaction takes place in electrolytic cell. So here, what is a redox reaction? Both oxidation and reduction reaction simultaneously takes place. That is known as redox reaction. So those reactions in which both oxidation and reduction simultaneously takes place. That is known as redox reactions. Here, electrochemical cell contains two compartments, anodic compartment and cathodic compartment. In electrolytic cell, only one compartment contains both anode and cathode. There is no specific compartments for anode and cathode. Both the anode and cathodes are dipped into the same compartment, which contains electrolyte. Next, in electrochemical cell, anode is negative and cathode is positive. So oxidation takes place at anode and reduction takes place at cathode. Whereas in electrolytic cell, cathode is negative and anode is positive. Why? Because due to the presence of external source in electrolytic cell, sign of the electrodes will be changed. Sign of the electrodes will be changed due to the presence of battery in electrolytic cell. And coming to the electrochemical cell, salt which required. So the salt which is used to neutral the both compartments of electrochemical cells. Whereas in case of electrolytic cell, salt which is not required. Why? Because here both electrodes are dipped in one compartment which contains electrolyte. So here there is no use of salt which in case of electrolytic cell. So these are the major differences in between the electrochemical cell and electrolytic cells. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.